If you set up a camera in your home or office right now, it will happily record hours of continuous footage. But storing video data is very different from actually understanding what a camera is looking at in real time. To bridge that gap and build a camera that can actively describe its environment, you quickly hit a massive hardware wall. Historically, running vision language models required thousands of dollars in dedicated, power-hungry GPUs. This diagram illustrates the two traditional pipelines for video analysis. If you lack the heavy local hardware, you are forced to wire your camera to the internet and continuously stream your private video feed to a remote cloud server farm for processing. This offsite approach immediately sacrifices your data privacy, as raw footage is extracted to corporate servers. It also leaves you with a perpetual ticking meter, running up expensive API costs for every single frame analyzed. We clearly want the security and accessibility benefits of continuous smart monitoring, but these financial, hardware, and privacy barriers have kept it out of reach for everyday deployment. The SmolVLM2 Edge Vision Agent is an open-source framework built to bypass these industry bottlenecks. Interestingly, the architecture for this agent was not written by a human engineering team. It was generated autonomously by an AI coding agent named Neo. The resulting system requires no GPUs, incurs zero API fees, and operates entirely offline on a standard computer with 16 gigabytes of RAM. By removing the requirement for a GPU, this architecture shifts advanced computer vision away from massive tech corporations and puts it directly into the hands of individual users. To see how this runs smoothly on standard hardware, let's track the data from a physical event, like a person who pushes open a door and steps into a room monitored by a standard webcam. This timeline visualizes the core data density problem. A standard camera generates 30 frames every single second. Pushing that continuous, rapid flood of image data into a neural network will immediately choke and freeze a basic CPU. To survive the data flood, the system uses a core defense mechanism, a motion detection gatekeeper built on a concept called frame difference calculation. Instead of forcing the heavy AI to watch an empty room, a highly efficient, lightweight script simply calculates the specific pixels that change from one frame to the next. If nothing moves, the AI stays completely asleep. The moment our figure enters the frame, the pixel difference spikes. When that calculated change crosses a specific programmed threshold, the script instantly wakes up the vision model for analysis. This selective triggering filters out the vast majority of useless data, leaves a high-class processor running cool, frees up system memory, and guarantees every movement is captured. Intelligent software architecture that knows precisely when to ignore empty space allows for continuous monitoring without the need for brute force hardware scaling. Once the gate opens, the captured frame is handed over to the Hugging Face SmolVLM2.2.B model. This visualization shows what makes this specific model capable of the task. It is a highly compressed 2.2 billion parameter multimodal model explicitly engineered for CPU inference rather than cloud execution. It analyzes the image to describe new objects in the scene and can accurately read text directly from the environment, pulling words off whiteboards, signs, or receipts. This dashboard shows the final output. The AI parses its findings, assigns a percentage-based confidence metric to its analysis, and permanently logs the structured text alongside a captured thumbnail image. All of this data is stored cleanly inside a local SQLite database and served up to a fast, searchable web interface hosted entirely on your own local network. From the optical capture of the motion to the complex text analysis, down to the final database entry, every single step happened locally. It proves that advanced multimodal analysis can be securely vaulted directly on your device. By eliminating the need for expensive GPUs and cloud subscriptions, the SmolVLM2 agent removes the primary financial and technical obstacles to deploying real-time AI vision. Developers can now build intelligent systems for home security or accessibility tools, using hardware they likely already own. This model of edge AI executes powerful analysis locally, processing data at the exact point of its creation to ensure privacy and speed. High-performance AI is moving out of server farms and into the background of everyday devices, running quietly on the edge.